All right. Hello there, everyone who was not able to make it to our live lecture today. So during the live lecture, what we did is we went over this review for your summative assessment that is on Friday. So when I say summative assessment, it's a test, it's a quiz, whatever you want to call it. We don't have like a separate category now. So this is, for all intents and purposes, like your test. So important thing that I need to point out right now so that nobody has any questions about this. And if you are, again, watching this recorded lecture, this should be at the top of your notes that you send me, the day and time of this assessment. So this assessment will be open on Friday, this Friday, April 24th, from 8 a.m. to 11:59 p.m. Okay. So if you try to get on to this assessment before 8 a.m. on Friday, so if you try to log on tomorrow, you're not going to see it open. You won't be able to access it. Okay. It is only open from 8 a.m. to 11:59 p.m. on Friday. After that, then it's closed. Okay. So 0 if you don't get it done by 11:59 on Friday, and taking a 0 on the summative assessment would not be a good idea. So make sure that you write that down in your planner. Make sure that you block out some time. It will be 14 questions, so it'll take a little bit of time. You will have to show your work on some of them, but make sure you have that time on Friday. Okay, let's get into the actual review to talk about what's going to be on this summative assessment. So this assessment is over rational functions, which, remember, when we're talking about rational functions, we're just talking about functions that have some variable in the denominator. So we have some fraction where there's a variable in the denominator. Okay, so the first thing that we did with this, we had to go back to like middle school where we learned how to add, subtract, multiply, and divide fractions. So all of those things are going to be on there. And you need to be able to convert mixed numbers to improper fractions and then like add, subtract, multiply, divide, and then simplify. So that's the first couple questions on there. Then the next set of questions is going to be multiplying and dividing rational expressions. So now we have fractions, but now we have variables with those fractions. You have to remember multiplying straight across, simplifying, things like that. Then we had adding and subtracting rational functions. So that's where you're going to have to remember things like the least common denominator. You're going to have to find that, then make the least common denominator, then add or subtract, and then simplify. So that's adding and subtracting rational expressions. After we did that, then, and this is more recently, like distance learning 2.0, we had solving rational equations. So that was using the cross multiplication method. And you are going to have to use the cross multiplication method and be able to show your work. So if you didn't watch that lecture, or if you didn't really like listen to it or internalize it, if you show your work any other way for those problems, they're going to be wrong, because cross multiplication is the easiest way to solve any of those problems where you have a ratio equal to another ratio. So that's that. And then we had the most recent stuff, and that was identifying the vertical and the horizontal asymptotes. So you're going to have to do that from a graph, which is relatively easy. You also have to remember that either x equals or y equals, so that's important. And then you're also going to have to do that from an equation. So if I give you an equation, you have to be able to tell me where is the horizontal asymptote and where is the vertical asymptote. Okay. So these problems that I'm going to do in these next couple minutes here, all great practice questions for the test. So if I were you, I would take the practice questions that I give, change up the numbers a little bit, and see if you can still solve those problems. If you can still solve them, then you're going to be good to go for the test that will be again on Friday. All right, so let's get into it. First questions, this is multiplying and dividing fractions, okay? So if we're looking at these questions, the first thing that we're going to have to do is turn any mixed number into an improper fraction. Or in this case here, where we have 2/3 times 5, we're going to have to turn that 5 into some fraction. So if we think about it, well, 2/3, that's 2/3, and we're multiplying. Well, 5 is the same thing as 5 divided by 1. So we can rewrite that whole number 5 as 5/1. And then all you have to do is just remember the rules for multiplying fractions. You multiply straight across. So 2 times 5 is 10. 3 times 1 is 3. If there was some common factor we could divide out, we would do that, but we can't. So the answer for this one would be 10/3. pay very close attention to the directions here. It says your final answer should be written as an improper fraction. That's 10 over 3 in its simplest form. Again, we can't divide anything out of 10 and 3, so that's in its simplest form. Okay, do not convert that back to a mixed number. All right. Let's go ahead and move on to the next question. So in the next question here, we are dividing fractions. So if you remember, dividing fractions can be easily turned into a multiplication problem by multiplying by the reciprocal. So 2/3 divided by 1/4 is the same thing as 2/3 times 4 over 1. And if you remember, multiplying fractions, we multiply straight across. So 2 times 4 is 8, 3 times 1 is 3. And then if we could divide something out, we would. In this case, we can't. So 8 over 3 is going to be our final answer. Again, your final answer should be written as an improper fraction in its simplest form. 8 over 3, it's an improper fraction in its simplest form. Okay, let's go on and move on to the next one. Okay, in our next problem here, this is where we're getting into adding and subtracting our fractions. So the first thing that we would need to do in this problem is convert this mixed number, 2.5, into some improper fraction. So if you remember, we multiply the denominator by the whole number out front and then add it to the top, put it all over this denominator. So 2 times 2 is 4, plus 1 is 5. We're putting that over, that doesn't work, 5 over 2. And then that's added to 2/3. Okay, so this is not as easy as just like adding straight across. We cannot do that when we're adding and subtracting fractions. So when we're adding and subtracting, remember, we need to find that least common denominator. So we need to find some number in the denominator that if we multiply our current denominators by some factor, we can get there. So if you think about it, well, 2 and 3, they both are factors of 6. So we could pretty easily find a common denominator of 6. And you can think, okay, well, how do I turn a 3 into a 6? Or what do I need to multiply 3 by to get to 6? Well, in order to get to 6, I have to multiply by 2. I can't just multiply by 2 in the denominator. I'm only allowed to multiply by something over itself, because remember, 2 over 2 is equal to 1, and 1 times anything is itself. So this is just going to turn this old fraction into 4 over 3 times 2, which is 6. And we're going to do the same thing for our first term. So we have to think, okay, well, what do I have to multiply 2 by to get to 6? 2 times 3 is 6. I can't just multiply my denominator. I also have to multiply my numerator. So 3 times 5 is 15, and 3 times 2 is 6. Now that we have a common denominator, with fractions, we add the numerators, keep the denominator the same. So 15 plus 4 is 19 over 6. Again, if we could simplify that, if we could divide something evenly into 19 and 6, we would, but we can't. And it's asking for the final answer as an improper fraction in its simplest form. So 19 over 6 would be our final answer. Okay. Let's go ahead and move on to some subtraction. So this one is saying subtract. And again, the rules for addition and subtraction are the same when we're talking about fractions. So we're going to need to get some common denominator. So we're looking at 3 and 4, and we're thinking, okay, well, 6. Well, 6 is divisible by 3, but it's not divisible by 4. 8, well, 8 is divisible by 4, but it's not divisible by 3. 9 is divisible by 3, but not by 4. So the lowest number that's divisible by both 3 and 4 is going to be 12. So we know that's going to be our common denominator. And then again, we need to think, okay, well, what do we have to multiply 4 by? We'll start with the first one. So what do we have to multiply 3 by to get to 12? Well, 3 times 4 is 12. We can't just multiply the denominator. We also have to multiply the numerator, because 4 over 4 is equal to 1. 4 times 2 is 8, and then 4 times 3 is 12. And then over here, okay, well, what do you have to multiply 4 by to get to 12? 4 times 3 is 12. We have to multiply the numerator as well. So 1 times 3 is 3. Now that we have a common denominator, we can add across the top, or in this case, subtract across the top. So 8 minus 3 is 5. We keep the same denominator. 5 over 12 is going to be our final answer. If we could divide something evenly into 5 and 12, we would cancel those out, but we can't. So 5 over 12 is the fraction in the simplest form. Okay, so those should have been pretty easy. That's just review, like I said, from middle school, no problem there. But all those concepts, like finding the least common denominator, multiplying straight across, those are all going to help us when we get to these rational expressions. So let's go ahead and look at this first problem here. This first problem, it says multiply and simplify. So the rules for multiplication of rational expressions are the same rules that we had for multiplying regular fractions. So we multiply straight across. So 2x times x would give us 2x squared. And then we had, actually, you know what? Let me clear this out. Let's just go ahead and write this out first and see if we can cancel some things, because that's what we're going to end up being able to do. We're going to have 2x times x. That's in the numerator. And then again, if we're multiplying the denominator straight across, we're going to have x times x plus 1. Now, the reason I didn't want to cancel these things out or multiply these things out or distribute is that if you look, this x is a common factor in the numerator and in the denominator. And when I say common factor, it's multiplied by the other factor. So this x is being multiplied by the 2x. This x is being multiplied by the x plus 1. So we can cancel it out because it's in the numerator and the denominator. Remember, x divided by x is just equal to 1, and 1 times anything is itself. So 1 times 2x over x plus 1 is the same thing, and that's going to be our final simplified answer. Okay, so the important thing to remember, multiplying, the rules are the exact same as when we were multiplying fractions. You multiply straight across. The only thing that's different here is that now we can look at these as factors. So if there's a factor like a variable, x, in the numerator and in the denominator, then we can cancel those out when we're simplifying. All right, let's go ahead and look at another type of problem with these rational expressions. So this is saying divide and simplify. And again, the reason that I had you do the multiplication and division with regular fractions is that the rules still apply. So we can rewrite this division problem as a multiplication problem. 2x over x plus 1 times x plus 1 over x. Remember, dividing is the same thing as multiplying by the reciprocal. So now when we're multiplying straight across, 2x times x plus 1 is in our numerator. And in the denominator, we have x plus 1 times an x. Okay, well, I can immediately see that x plus 1, that's going to cancel out. But then if you look, what I have left over is 2 times x in the numerator and then an x in the denominator. So I can actually cancel out these x's as well, and all I would be left with is 2. Okay. So again, dividing is just multiplying by the reciprocal. Once we've multiplied by the reciprocal straight across, then we can simplify by looking at what factors are in the numerator and the denominator and canceling those out. All right, let's go ahead and move on to the next one, where we're going to be adding and subtracting these rational expressions. So this says add and simplify. Again, the rules for adding and subtracting rational expressions are the same as numbers. So we need to get a common denominator. So if we're looking at the current denominators that we have x plus 1 and we have x. So if we're thinking about this least common denominator, well, it has to have a factor of x in it, and it also has to have a factor of x plus 1, and that's it. So that's going to be our least common denominator, x times x plus 1. So again, we're going to rewrite this as the same expression, but it's going to have a denominator of x times x plus 1 for both of these here. So we're going to have x times x plus 1 plus something over x times x plus 1. And then we have to say, okay, well, how do we turn this denominator? Well, we have to multiply these denominators by to get to this common denominator. So if we look at this first one, x plus 1 times x gets us to our common denominator. Well, we're not allowed to just multiply by x. We have to multiply by x over x, which is just 1. So if we do that, x times 2x would be 2x squared. Okay, let's go ahead and look at our second term. So right now we only have an x, which would need to be multiplied by x plus 1 to get our least common denominator. We can't just multiply by x plus 1 on the denominator. We have to multiply by x plus 1 over x plus 1. In this case, we'll distribute the 3, which would give us 3x plus 3. And so now all we have to do is just add straight across. Sorry, not add straight across, but add the numerators, keep the denominator the same. So we would have 2x squared plus 3x plus 3 all over x times x plus 1. Okay, and if we wanted to multiply this out again in the denominator, we could. So this is going to be the same thing as 2x squared plus 3x plus 3 over, we distributed this, x squared plus x. We could leave it like that. That would be perfectly acceptable as a final answer. Okay, so either of these would be acceptable. All right, let's go ahead and move on to the next one. So this is saying subtract and simplify. And again, the rules for addition and subtraction are the same. We need to get a common denominator. If you look at x plus 1 and x minus 1, there's no factors that we can take out of both of those that are the same. So our least common denominator will just have to be divisible by x plus 1 and x minus 1. So we have x plus 1 times x minus 1. That's going to be our new least common denominator. So we're going to have something over x plus 1 times x minus 1 minus something over x plus 1 times x minus 1. All right, well, let's look at this first expression. We have x plus 1 right now in the denominator, and we need to multiply it by something to get to x plus 1 times x minus 1. Well, that's easy. We just multiply by x minus 1. Can't just do it to the denominator. We also need to do it to the numerator. So we have x minus 1 times 2. And if we distributed this 2, this would give us 2x minus 2. And then we have minus. Okay, well, in the second term, we had x minus 1. So to get to x minus 1 times x plus 1, we would need to multiply by x plus 1. We can't just multiply by x plus 1 in the denominator. If we do it in the denominator, we also have to do it in the numerator because we're allowed to multiply by 1. That's allowed. Again, we're going to have to distribute this x here. So this would give us x squared plus an x. All right, and so now that we have this common denominator, we can do the subtraction. I like to think of like, okay, we're going to distribute this negative. We have a negative x squared and a negative x. So if we're writing this out, we'll start with the negative x squared. And then we had a positive 2x minus an x. So that would just give us an x. And then we have minus 2, and that's just going to be minus 2. So that's all over x plus 1 times x minus 1. All right, now, if you're looking at this one here, we might be able to simplify it, okay? So if we can do some factoring, that's what we're gonna wanna do next to be able to actually see if we can cancel out some factors in the numerator and the denominator. If you look, we have a negative as our leading coefficient, and that's something that is kind of hard to deal with. So if we can factor out a -1 from this top, then that'll make things a lot easier. So we're going to rewrite this as -1 times, and then we'll have a positive x squared minus an x, and then plus 2. And that's all over x plus 1 times x minus 1. Now, the reason I did that is we might be able to factor this. So if you think, okay, what are the things that will multiply to give us +2 that add to give us -1? Multiply to give you +2, add to give you -1. There aren't any. We can't factor it. So this would just be our final expression right here. We could write it like this. We could write it like this. Either way, you'll see on the test, it'll be in multiple choice. So you'll have to figure out through multiple choice, do I have to multiply these things, I have to factor it. But that would be your final answer. So this would be an acceptable final answer too, because there's nothing that we can factor out. All right, let's go ahead and move on to the next one then. Okay, so now we're on to the asymptote questions. And I think the graphing ones are pretty self-explanatory. You just need to understand the definition of an asymptote. So if you're looking at this graph, if we're thinking about a horizontal asymptote, think about horizon, that's side to side, the imaginary line on this graph that the curve never touches. So for a horizontal asymptote, your equation is always y equals, and then it's whatever that y value is that your graph never touches. So in this case, we have a horizontal asymptote at y equals 1. This is horizontal. And then if we're thinking about a vertical asymptote, that's the vertical line that your graph will never touch. And in this case, our vertical asymptote is at x equals 0. So that's your vertical asymptote. Another name for a vertical asymptote, remember, is the excluded value. So both of those, they're used interchangeably. If I ask you for the excluded value, I'm asking you for the vertical asymptote. And again, that equation is x equals. All right. So that was the graph. Now, if we're looking at asymptotes from an equation, it's a little bit different, okay? So if you think about back to what I was saying with the vertical asymptote, another name for the vertical asymptote is the excluded value. And the reason that we call it an excluded value is that it is the x value that we are not allowed to have in this equation. And you can think, well, why is it excluded? Dividing by 0 is an absolute no-go. Absolute no-go. Cannot divide by 0. So what would be that value that would cause us to divide by 0? Well, in this case, we have -2 divided by and then x plus 3. So if we plugged in -3 here, -3 plus 3 would be 0. Then we would have -2 divided by 0. We can't do that. So in this case here, the excluded value is going to be x equals -3. Okay. Another way you can look at it is just set the denominator equal to 0. So x plus 3 equals 0. If I'm solving, -3 minus 3, x equals -3. Okay, now if we're talking about the horizontal asymptote, you have to think. X is getting really large. Okay, so we're going to plug in a really, really, really large number, and we're going to try to see what happens to y. Okay, so in this case, if we had -2 divided by this x plus 3, if this x was 1,000,000, okay, and again, I'm just talking million, it could be a billion, it could be a trillion, a really, really, really large number. -2 divided by a really, really, really large number is like 0.0000000. It's like 0 pretty much. So as this x gets bigger and bigger and bigger, this whole term goes away. It goes to 0. Well, then that means that y must be getting closer and closer and closer, not to 0, because it's not just this 2 over x plus 3. It's negative 2 over x plus 3 plus 1. So as this term gets closer and closer to 0, which happens when x gets bigger and bigger and bigger, this y gets closer and closer to positive 1. So in this case, our horizontal asymptote would be at y equals positive 1. All right, so that is pretty much it for what you will see on your summative assessment. So again, my recommendation, big time recommendation would be if you're struggling with any of this, I have office hours. I'm gonna have office hours tomorrow, and I'm gonna send out an email tomorrow morning just reminding you, but the office hours have changed. So I'm not going to have office hours during the test. Obviously, I'm not gonna help you during the test, but tomorrow I will have a separate set of office hours, and they're gonna be in the morning, I think right around 9 o'clock. So I'll send you that email today to confirm that. But again, there will be no office hours on Friday. If you need help with this, I'll have office hours tomorrow. The other thing that you can do is IXL, because all of these problems that are going to be on your test are going to be coming from the IXL practice that you've been doing. So good luck. Make sure that you take that test on Friday, and I will see you all on Monday.